Let's take a look at method number 1 of backup and restore technique. First we need to generate the load. I have created queries to load the data. So this will keep looping through and inserting the records into the employee table. Okay, so we are executing against node 2, supposed to be generating the data on node 1. This is node 1 is the source. Gender, department number, department, let us say 1. Okay, now this is inserting rows into the. Alright, it started inserting. As you can see, the sequence number 1 2 3 4 like that. Okay, it started inserting. Now the load is getting generated on the source table. How about target? Okay, target. Okay, let us stop the target. ER star stands for extract replicate, all extracts and replicates. Okay, we stopped all the extracts and replicates. Now let's do the same on target. Okay, so we don't want any extracts and replicates to be running, but we added trend data. Now we have the supplemental logging going on in the database log. Now let us see how many records it inserted. Some bunch of rows. It's still going on. Okay, every 5 seconds it passes for 5 seconds and insert a row into the employee table. Okay, now let's take a backup of this source database and restore it on the target. Okay, this is the file. Let's move the file to node 2 C drive. Okay, so let's go to target database. and restore the database. Okay, so I don't want to overlay this database. I'll create a new database. Okay, I will okay, so let us say backup method 1. This is my database name. I will select backup file. Why I don't want to restore? Because I have defined several other columns. Okay, the structure of source and target is different. Okay, so I don't want to disturb the structure, because I wanted to give demo on several other methods. So that's why I selected creating new database for target. Okay, in the meantime, let's open the ODBC. Okay, bk method 1. This is the database that we restored. Let's point the ODBC to the new database. Now we don't need to change anything in the replicate parameter file, because replicate parameter file uses ODBC name. So in the ODBC connections information, we change the database name from target DB to bk method 1 DB. So that's it. So we will be working now. Our target database is this, because that's what the ODBC connection refers. So this database on the target is what we whatever the data that we took backup, exactly the same copy here in the target server. Now let's go to the source. Now we need to start the extracts and replicates from where backup ends. First we need to find out what is the last LSN that backup took. Okay, as you can see, still the script is going on. It is continuously loading the data into the employee table. Okay, so definitely backup will not be having the up-to-date current. Okay, it might be having some information. So okay, so let us see what is the current value of EMP table in the source. Okay, right now it is writing record number 81. In the target, select bk method 1. So it has record up to 35. So we need to replicate from 36. If we start replicating from 36, we are fine. Okay, so we don't need to handle any collisions, because there won't be any collisions to handle. Okay, so but we should be able to exactly identify what is the LSN from employee number 36. Okay, if you can identify that, then we are good to go. Okay, for that you need to look into the MSDB database. Okay, in the whenever you take backup, okay, so when you take backup, the backup file name, the first LSN, last LSN, okay, so everything about the backup will be stored in one of the table, backup media set, backup media family, in the MSDB database. Okay, so you need to browse the MSDB database to find out the first LSN, last LSN, those information. Okay, okay, this is the table that you need to browse. Okay, so I already written the query. because I don't want to keep searching for the query, the column names and all those things. But let's take a look at the columns, whatever the entire list of columns in that table. Okay, so this is how it will be like. So database name is here. Okay, so the file name, where exactly the backup file is, or the exact physical path of the file will be stored in backup media family. Okay, you need to look into the media family table to get the physical file name. But in this case, we don't need the physical file name because we already restored it on target database. We need to know the last LSN. Okay, so there is a last LSN here. If you take a look at okay, so here the last LSN. This is the last LSN that this backup contains. Okay, so I eliminated all the unnecessary columns. And I took the required columns for this demo. Okay, we need the last LSN. Okay, and that's pretty much it. That's all we need. But in the backup set table, if you observe, the LSN is written in the decimal format. But whereas now you have the extracts and pumps and replicates, all the groups. Okay, now you need to start the extracts. You need to start the extract from this LSN. Okay, you need to, this is the last LSN. Okay, you need to start the extracts from this LSN. Okay, but extracts, GoldenGate, okay, it knows the hexadecimal format of the LSN. Okay, LSN has different formats: hexadecimal format, decimal format, and there are several formats of LSN. Okay, in the backup set table, it tells us the LSN in the decimal format, but we cannot give this decimal value when we are asking the extract to start from that value. We need to specify hexadecimal value. Alter extract start from hexadecimal LSN, but we don't have hexadecimal LSN, we have the decimal LSN. So we need to convert decimal LSN into hexadecimal LSN. Okay, and give this hexadecimal LSN while starting these extracts. Okay, so Microsoft has given a function where we can pass the decimal LSN and get the hexadecimal LSN. Okay, you can note down this name: function fn convert numeric LSN to binary. In the Google, you will see the Microsoft the complete script of that function. Okay, I just downloaded that function, and I have that function in my database. Okay, now using that function, I'm able to convert this decimal to hexadecimal. Now source DB, I took backup 3 times: 10, 11 a.m., 11:45 a.m. and 3:09 p.m. This is the backup file we just took and restored it on target database. Okay, target server. So this is the LSN we need, but we don't need the decimal, so we'll go with hexadecimal. Copy that. So now, before altering the extract to start from this LSN, I just wanted to show you some information about the log file, how the transaction log file look like, and what those information, So this is the last LSN. Now let's copy this hexadecimal value. fndb log, browse the active transaction log file. I just want to browse the log file from this LSN. Now let us browse the hold on, instead of saying select star on order by lesson. So as you can see, this is the LSN that backup ends. Okay, last LSN. If you see that LSN, it says backup has completed, backup commit. So this is the backup last lesson, and from here, if you take a look at the next transaction, immediately after the backup, you will see the insert is going on because the load is continuously inserting rows into the employee table. Okay, there is insert going on. Okay, begin transaction. Okay, the begin transaction, this transaction ID, if you look at the backup LSN, you can see this is the final LSN of the backup. Okay, and this is the next insert statement. Okay, if you see allocation unit, it is employee table, and it is inserting the rows. Okay, the insert, you can see what you can see the other columns here. Okay, so you can also say select star to see other columns, but okay, for now let's I just want to show you that if you say okay, start capturing the transactions from this LSN, there is nothing to capture here. Okay, so ideally we would like to start here, but that's fine to start here because this is the backup completion LSN here. Okay, there won't be anything in this transaction ID. Okay, these are zeros, which doesn't matter, it starts from here. Okay, if you know this number exactly, you can do this, but in the huge transaction log file, it's difficult to find this exact number. But you can always say start from here, start capturing from here. Okay, which is the last backup LSN. Okay, that we found from MSDB table. Okay, so capture this LSN. Okay, that means this LSN. Okay, so now let's say alter gg. I think one is employee, I guess, from okay, one is employee. Okay, now let's say this is important command ggec01g1 lsn. You need to specify 0x. Okay, because this is a hexadecimal value. Okay, if it's a decimal value, then you can say you can specify the decimal value here. Okay, either way you can specify, but I guess it just takes as hexadecimal value. Okay, so here ultimately what I'm doing is I'm altering the extract to start from this LSN. Okay, I have to do the same thing for every extract because every extract has to start from this LSN. Okay, alter it. Let's start it. It started capturing. It says 184 records has been inserted. Okay, so 184, here it contains 35. Why? Let's take a look at the login. Okay, so what is the file name? .g1004. Now you can see my last name underscore 32, that is the last value in the target. But in the trail, if you see, it started capturing from 33. That means we got it right. We started exactly where it stopped. If I run this trail file on the target, then it's going to work from 33. Then I don't need to handle any collisions. So now let's start the pump. Now my extract is running. It's not starting. It looks like we changed the database. So let us see the report file. Oh, checkpoint table. Yes, uh, we need to move the checkpoint file because we have to. Let us do the export import. Otherwise, we have to create the checkpoint table using the globals file. So again, we have to run the command add checkpoint table. Then it will create. We can also do that. Add checkpoint table. In the database. There is already a checkpoint table. Where is it? Okay, now it created the checkpoint table on this database bk method 1. Otherwise we have to export from here to here. Okay, so either way, but this is simple, adding checkpoint. Again stop. Now this time it says fail fetching error for select operation. It says you don't have that information. Okay, all right. Instead of worrying about those things, I would say I will export the data. because I already have the structure there. I thought it will work, but after it abandons, it expects the row and the checkpoint information. So because we are not doing right from scratch there, we are just kind of doing some backdoor information. No. Okay, we copied the checkpoint rows from here to here. Okay, now I think it should be able to start. Now it says it abandoned. Hmm. Now let's take a look at what the problem this time. Error in call map class. Okay, so we have the GG last modified date. We have additional columns in the target. You know the reason. That's the reason why I did not restore it on this database, because some additional columns in these tables. Now I have created some mappings in the parameter file which are failing to map because we exactly restored the source database here, and this doesn't have that extra columns for the mappings. Now we need to comment out extra mapping. Okay, so instead of this extra mapping we have to remove. Because we don't have this column in the target table now. Okay, now it's running. Now let's take a look at our employee table. Okay, not target table, bk method 1 table. Okay, 30, 31, 32, 33, everything is fine. We started inserting right after the backup file. Okay, so we didn't have any problem. The replicate is running fine and inserting all the rows. Okay, so there is no collisions. So okay, so this is how you do if you are working with backup and restore, and you need to start from where backup ended, the LSN. Okay, but this requires the source database and target database to be of the same structure. So when you restore, obviously the target database will be of same structure as source. So you can follow this method if you prefer to do not to handle the collisions, but there is another method how you want to handle the collisions. So let's go through this method. In this method we already added the tran data, and now extract is capturing. We have added the tran data and we started the extract. Even now we have the extract still going on. Now let's stop the pump. Stop the pump. So I stopped the replica. Now we are going to stop the pump. Okay, we just have the extract running and capturing the source transactions. Now let's take a full backup again and restore. So now we have taken the backup. This is our new backup file. Okay, now the source which started capturing before we took the backup. There might be several records uh, that backup file contains which are already there in the source trail file. Okay, when I take the trail file and apply it on the target, now it's going to collide. The data is going to collide. Now in that situation, you need to add the handle collisions on the target side. We will first replicate without the handle collision to see if it abends. Okay, it should abend because there is a data overlapping here. So now we took the backup. We will take this backup and restore it on the target. It will error because we already connected the open sessions, so we need to change this. Still it looks like there are some open connections. Okay, we changed it. Let us restore this database. Okay, in the meantime, let's modify the ODBC information. There is no bk method 1, so now it refers to bk method 2 database. Now we restored the database, so we don't have the checkpoint file again. It's going to create problems. So what we'll do, proactively we copy the checkpoint file. We have the, so this is our new database. So let us see how many records it has. Okay, it has records up to 357. Now let's take a look at the, let's start the extract. Before extract, I think extract is running. Okay, so let's take a look at the pump checkpoint file, because that's Okay, pump checkpoint is current read 58807 in the sequence number 4. That 58807 is the RB, relative byte address, in this sequence number 4 file. Okay, so what is this? G1 G10004. That's what the file we need to look into. Okay, G100 file. In this file, let's open that file in the log dump. Now the RBI is 58807. So you can say POS 58807. So right now the pump is pointing to this record. That means pump is going to retrieve from this record. Okay, so pump is going to send from 343. From 343. Now let's take a look at okay, 357. So what is this say? 343. So now pump is going to send from record 343, but we already have the 343. We have records up to 357. So now it's going to error out saying that 343 is already there. So let's do that and see what it says. Now pump started sending. Okay, let us see status. Okay, 114 records it sent. Now let's start the replicate. Abandoned. Expected. This is expected because it couldn't insert even one record because the first record 343 has problems. That record is already there. 343 or 443, whatever. Yeah, 343. Okay, so so let's take a look at the report file, the report. So sort by date and discard file. Okay, discard file is going to say 33. Okay, where it is reading from? Probably we should have row. I guess since we are working with the previous values, so okay. Now let's take a look at the report file. Okay, duplicate value is 36. Okay. Now, since we are combining the multiple test cases, we got stuck somewhere. So, but ideally, it should say the record 343. That means we should be able to. Okay, let us see the pump. Okay, info ggpc01 show ch sequence number 2. We should have rolled that, then it will be easy for us to identify. Okay, I guess we might be dumping the same rows into the okay 1G002 347. sequence number 2. Okay, that is the file. You can see I'm looking at the pump. Okay, pump says I am writing sequence number 2 on the target. This is my write position. Okay, I am writing sequence number 2. This is the RBA that I am writing to. Okay, 1G is the file. So 1G 000002 is the file that I am currently working with. But let us take a look at info ggrc01g1 show ch. What is this file is working with? See, actually this file is working with sequence number 1. We should skip the sequence number 1 and ask the replica to start working from sequence number 2, because for our method 2 we have been generating the file sequence number 2. So in order to do this, what we have to say, what is the status of replicate? Okay, abandoned. Okay, that's fine. Alter ggrc01g1 et rollover. Okay, that's fine. It is not valid for this. You have to say et rollover for pump, but you don't need that there. So what you can do, xds sequence number 2. Okay, sequence number 2. It will start reading from this file from beginning. Okay, the RBA is 0, that means beginning. So now when we say start rc01g1, it is going to append, saying that I cannot insert record 343. Okay, we will take a look at that in the report file. So if you see that duplicate key value is 346, 1G002. It should say 343 because 343 is already there. So why it didn't say 343? It directly went to 346. What is that? Oh, 343. 343 is 346 number. Okay, employee number 346. That's what it says. Employee number is 346. I cannot insert 346, which is there in the trail file, because we took the backup after the extract started capturing, so there might be some overlap. So how you want to handle from 346 some 357. Okay, so there are some bunch of rows. This is what is called as data overlap. Okay, so you need to handle these collisions. So in the report, sorry, in the parameter file, you have to say there are two options for you to do this. You can use handle collisions, otherwise you can say rep error default ignore. If it finds an error, just ignore it, keep continuing. But handle collision has some extra options. It has some built-in logic to handle this kind of scenario. These parameters specifically used, or the logic is specifically handled for this parameter. So it's good to use handle collisions instead of rep error ignore. There is one more option you may have to specify in the handle collision, that is allow primary key updates. So you need to specify this parameter. So now let's save it. So what that parameter does, probably it's you can take a look at the reference guide. They have given. See here, they say use handle collision with allow primary missing logo to skip a update instead of. See, handle collision by default, it converts update into insert. Okay, if insert fails, then it just gives up. So why unnecessary logic? Just say I do not handle primary keys, just ignore it. That's what it meant. So even you don't specify it, it's not a big deal, but it's it's good to specify. So as long as handle collision parameter is there, you are fine. So now if I restart, it's going to work fine. We have handle collision parameter. Okay, doc. Now, okay, before restarting, let us see how many records. 360. It says total inserts 230, total insert collisions, because 15 records there is a data overlap, so it collided. These data it just ignored. Handle collision just ignored it. Whatever insert, update, delete, insert might have duplicate, update might have missing rows in the target to update, delete might have there is no row to delete. So those kind of errors handled by the handle collision parameter in the replicate file. And now the data is in sync. Now since data is in sync, now what we can do, send replicate ggRC01 G1 no handle collisions. No handle collision, that means, but the parameter still has the handle collision. Okay, but you can pass an additional parameter to the running replicate to say that I don't handle the collisions from now on. Okay, so but you are not stopping the replicate. You are runtime, in the runtime you are passing the parameter. Alternatively, you can stop the replicate, go to the parameter file, and where is that handle collision? Okay, and you can comment it out and start it. Both are same. Okay, the thing is you have to stop and start. There will be delay. Okay, you have to stop it, change the parameter file, and you have to start it. Okay, so if it is acceptable in your environment that you can stop and start, then you can do this. But if you don't have that option, then you can send a parameter run in the runtime using this command. Okay, for the running replicate, you can say, okay, now you don't handle the collision, stop, because the data is already in sync. I know the data is already in sync. Now you stop handling collision. But the parameters file still has handle collision. If you stop and start the replicate, for example, you issue this command. Okay, for the runtime replicate process, you say no, you don't handle the collision. But for some reason the replicate abandons, or you stop and start, it is going to read again what is there in the parameter file. The parameter file still has handle collision, so that risk is there. So generally what people do, what we prefer, run this command. The data is in sync. Run this command to send this no handle collision to the runtime replicate, and after that go to parameter file, comment out that handle collision. Okay, so if somebody restarts, or if it abandons and you restart it later, and that time it's going to read from parameter file, and the handle collision is going to be commented out, so you'll be fine. Okay, but you have to remember to go and comment out after executing this command. So basically this is the method number 2 of how you go about it, using the handle collision in the backup and restore methodology. But you should be knowing handle collision. Okay, not all the time you will know the exact location, exact lesson to start with. That is, it is difficult to find that from the export import method. So for example, if you are following export import, this method to synchronize the data, to load the initial data, then you will not be knowing the lesson to start with for the extract. Okay, in that case scenario, you have to know how to handle collision. But if you are following the backup and restore technique, then you know where the backup ends, where the backup the last LSN in the backup, so you can start from there. So option, it's up to you how you wanted to handle. So now we have completed backup and restore technique. Okay, now let us work on initial load. This is GoldenGate. GoldenGate provides initial load mechanism, which is same as export and import, but it's a GoldenGate way of dumping the initial data into the target. Okay, so we will look into that. But in that scenario, initial load, even in that scenario, we have the option to find out where the initial load ended. Okay, whatever the initial load ended LSN, we can start from there. So we don't need to handle the collisions even in the initial load. So here you have to handle, because you don't know the exact LSN to start with. So okay, now our next approach is initial load. Okay, this is GoldenGate way of loading the data.